So, so thank you very much for the invitation. I'm very honored to be here. Thank you, Mr. Dover. Thank you, Steve. Thank you all board members, shareholders for listening to me. So I'm Fernando de Rizzo. I'm an engineer. I worked for Tupy for 33 years. Since 2003, I became responsible for global sales, and we have a major expansion globally with acquisitions and new business that we got. And in the last 7 years, until 10 days ago, I served as the CEO of the company. Okay, so just a little bit on our history with SinterCast. SinterCast is quite an important supplier, and significant part of our growth was based on CGI. So Tupy made good business when emissions regulations became more and more stringent. So this is the moment where the more technological, engineering-driven companies, they tend to grow in front of the others. And Tupy, although being a Brazilian company, nobody never knows, was a company that very much dedicated time to develop new technologies. Since the 70s, we invested significant amounts of money. Our first paper on CGI was published in 76. We started producing CGI in 91, making exhaust manifolds for Volkswagen. But that was not very major standard, was not very narrow, the limits of the CGI, so we needed a better control to the process. And SinterCast was the company that brought us the condition to control this process properly, and then we have a significant growth. We believe we had 60 to 70% of the global production of CGI, which now accounts for about 150,000 tons a year. We have eight SinterCast installations in our different facilities around the world. Okay, so just moving to my presentation, it's important that when you see our growth and what we have done a lot with SinterCast, that much more than a supplier, SinterCast became a business partner to us, to go to the customer, to provide them trust and confidence, to deliver such an important product. Engine blocks are very, very critical to the image of these OEMs. We are talking about equipment, they're capital goods that depend on these technologies, depend on the quality of its engines, on how they work, as it's linked to the image of these companies. And this has been very important, and it was very hard for a company from Brazil, had such a great expansion globally. Okay, we don't have any other Brazilian company in this area, in the auto parts sector, that has such a significant growth globally as we've done. So just presenting a little bit on Tupy here, let me give you, this is the necessary disclaimers, a lawyer request, but I'll talk a lot about the fundamentals of our strategic planning, the data we use to make the decisions we made at Tupy. It's important here to, as a reference, in the last 5 years, we acquired another engine block foundry and we acquired an engine company. We doubled the bet. As the world is talking about electrification, we decide to go the other way. And this is quite important to understand the reason behind we have to make these decisions. And we see a very bright future for Tupy, as I see a very bright future for SinterCast coming along with Tupy in this journey. So, a little bit about the company. Tupy last year recorded about 10.7 billion reais, which is about 1.8 billion euros in revenue. Okay, this means significant growth in the last 6 years. We grew 3 times in this period with the acquisitions and the process we did. Today, the company has 19,000 employees in different areas, in Brazil, in Mexico, in Portugal, in the US, in the Netherlands. We have 60% of our revenue comes from foreign markets, outside Brazil, and we run 6 plants today. Of our revenue, 40% comes from North America, 40% from South America, 15% from Europe, and 3% from Asia. And the company now is divided in 4 major areas. The company, the foundry itself is what we call structural components. And the structural components represents 80% of our revenue. We have 3 other new areas that we are expanding that are directly linked to structural components, which is contract manufacturing, which means adding value to the existing product we make. Energy and decarbonization is a new area that came from an acquisition of an engine company in Brazil. I will explain a little bit. And distribution is our sales of parts, aftermarket parts for engines that also came from this acquisition of MWM. So, the foundry itself, we are focused in casting components with high geometric and metallurgical complexity. And that's where SinterCast helps us. We serve all the companies in the West for capital goods. We dedicated this business to capital goods. So I'm talking transportation, trucks, railroads, forklifts. We dedicated to construction machines and to agricultural machines. In the last 20 years, we tended to step by step stay away from passenger cars because passenger cars was moving the other direction. And now we see another trend coming that we can bring us back to this business of passenger cars, and I'll cover later. And we're gonna need help from SinterCast in this process. Okay, so we have a global presence. We supply all the producers of light commercial vehicles, trucks, and agriculture and construction machines in the West. Some customers we are 100%, some customers we are 30%, but we are involved with all of them, and we are a technology supplier for them, technology partner for them, for new technologies, for new engines. We have plants in Brazil. We have 2 plants in Brazil for foundry, 2 plants in Mexico, and 1 plant in Portugal now. And moving the next business, contract manufacturing, you see there our assembly line. We assemble MAN engines in Brazil for Volkswagen trucks. And the idea here is to add value to what we do. We grew as a company in the casting. We became the largest foundry in the world for blocks and heads. And later on, the limits for our growth, we said we have an opportunity to grow vertically. Then we acquire MWM in Brazil, not MWM in Germany, which is owned by Caterpillar. Okay. As we acquire MWM, we brought the knowledge to add value to this casting. So we can do machining, we can do assembly, and we can do engineering services for engines. And this is the overall idea. And the green portion in this chart is the area that we believe we can grow. If Tupy could assemble all the castings we pour, this company could grow 30 times in terms of value, of revenue. And we believe this is a trend. We believe OEMs, as they did in the past, they kept their own block and head foundry internally. And we see even in Sweden, Scania and Volvo, they still hold their own foundries, although we are their second supplier for them. This tends to be outsourced. And as this business will be outsourced, we probably will be taking advantage of that. So, the other area is energy and decarbonization, which is a part that we use existing engines that MWM had to apply sustainable fuels. And this is an important area of knowledge to grow the business in castings. We have engines for biomethane that we replace, and engines in ethanol that we don't sell to OEMs. We replace engines in existing machines in the field. So here you have an idea for ethanol facilities of corn, of sugarcane, urban transport, or producers of cattle raising or pork raising. These companies, they can produce their own fuels. So they want to use the fuels they produce to operate their own machines. And this is the idea behind, and a lot of my presentation will be talking about that. And the last area, the engine spare parts that we sell, we have a distribution business because of the legacy of this MWM brand in Brazil. So, going back to our presentation, what drives our business? So, how to enable a better quality of life in the future? And as you look our three pillars, we're talking about freight, agriculture, and infrastructure. This is essential for life. This is critical: sanitation, housing, food, right? How they can live. And as we look in the world, and for us it's quite important because Brazil is very much reflected in this of inequalities we see around the world. You see the differences. The yellow balloons, you see the life expectancy of these different regions of the world. And we highlight two. We highlight Japan, which have a life expectancy of 85 years versus sub-Saharan Africa, where they have 62 years. And the difference basically is reflected in their energy consumption. Energy is absolutely critical for their life standards. And we need to provide energy at a low cost. If we cannot provide energy at a low cost, we will never change the life quality of these people. And this becomes an important area of business when you talk about sanitation, construction, when you talk about agriculture, transportation, and so on. As we look in the history, this is interesting. The history of consumption of primary energy are those sources of energy that we take from nature, okay? And as we continue accumulating and not having any transition, we are having addition of energy because we never consume as much coal as we are consuming now. We never consume as much oil as we are consuming now. And we are adding, and we need even more and more and more. And you see life expectancy grow. So the world can be better if we have more energy, right? But the problem is the emissions that this consumption of energy is creating. And as you see on the top, electricity is the most critical one. So we don't have enough clean electricity. Electricity is creating the major part of this problem. So solutions must account for that. As we look into the future, you see population will grow from 8 billion to 9.2 billion. GDP growth per capita is likely to grow 60%. People consume more. The first choice is to eat more proteins, consume more goods, and you need transportation for that. You need production for that. Today, 55% of population live in cities. We will have 70% live in cities. And also life expectancy today is about 72, 73 years. We'll go to 77 years. In this all four corners, you need more energy. There is no way you can improve this without more energy. We only have GDP growth if we have energy growth. That's why we need to find other sources of energy, right? And when I look back to our fundamentals, to the areas that we believe the business can grow, what do we see for transportation? Transportation is likely to grow significantly by 2040, 49%. This is the tonnage times the distance to be transported. And you see that you're going to have 50% growth. We need more machines running. There's no way we can do that with less machines than we do today. The same thing happens in infrastructure. We need much more infrastructure. The world is lagging on infrastructure. Even Europe or North America, because they need to revise their infrastructure, but we see areas of the world, like in Brazil, 90 million people don't have sanitation. We need to build sanitation for these people. If we go to Africa, the situation is even worse. And this, you need construction, you need machines, you need fields that can produce this work cheaply, economically. Other than that, it won't work. And the same thing goes to agricultural production. People grow, more people living longer, right? And richer. They're going to eat more protein. So you're going to need much more grains, much more proteins to serve these people. So, but then we have a paradox, because We have common needs, but we still see energy poverty, right? And we have climate change and need to fix that. How do we approach that? And part of this idea, as we discuss this within the company, what we're gonna do, because if we do the majority of engine blocks and cylinder heads that run on diesel in the West, this industry needs to change. And we need to be prepared for this change. How can we do that? So we always look, okay, we need to find solutions that are cleaner, but also economical. The solutions we have seen so far, talking about hydrogen or electrification, they're quite expensive. And they are not under the reach of the majority of this population. There will be business if these people can have access, if we can make this service at the cost we do with fossils, because even with fossils, we did not support these people, but we need to do better than that, right? So, and then we see governments trying to make the decisions for technologies. Governments should not make the decisions. Companies should innovate, and the innovation of these companies should bring in new technologies that we should be awarded for decarbonization. If we can decarbonize, no matter how, we should be awarded. Not the government tells, oh, it should be electric, should be engines. No. That's we've been trying to tell our local government and globally, and that's what drives our innovation initiatives. So we see a lot of still of opportunities that we call viable decarbonization. And this is a free translation of Portuguese, but when we say viable decarbonization, we are talking about situations where I decarbonize and I also reduce the cost. I create economic efficiency for the overall economy. So I'll get more business if I am cheaper. So moving on. When you look into our applications and you see a lot of sources here that we put together in this, this is the condition today when we say the carbon footprint of each solution for transportation and the total cost. So you see electric in Europe is quite expensive and the carbon footprint today is quite high. But why companies are investing in this? And that was what we were trying to understand. And when we look into all the solutions, we said, okay, what's the expectation of improvement that we see in the future? And that comes to this chart. So that's why companies are doing this. They say, okay, let's look in the assumptions behind this. Why do they believe electric will be so cheap and will reduce their carbon footprint? And the reality, I mean, we couldn't find a solution, because to reach that figure, we should increase renewables from 25 to 80%. It won't happen in 2040. We should reduce cost of electricity by 20%. It will not happen as well, because all the new sources are coming more and more expensive. The cost of minerals, which are limited globally, should reduce by 50%. So then you would have expansion, right, and reduce the cost. Battery life should go from 300,000 kilometers to 1 million kilometers. Very far from where we are. And also infrastructure. You need the ample charging stations every 100 kilometers in any road around the world. This is quite hard. When you look at the total cost of ownership and we separate and we start talking here about sustainable fuels, what kind of a sustainable fuels we could use? And then we found these figures, we serve you later, but you see that all the situations that you have liquid fuels that you can produce out of crops or out of waste, we can keep the costs very similar to where we are with diesel. Okay? When you look into hydrogen, which is the other source, when we compare hydrogen to diesel today, you see the cost of diesel in Europe, what's production, distribution, and taxes, and then what's the cost of hydrogen in total today, 2022, and what's expected to be 2035. This is also very expensive and will continue to be expensive. It will only work if it has subsidies, because the cost for the majority of the people, the cost of transportation, the cost of everything would increase substantially if we look for the solution. But then we come to sustainable fuels and wasted energies. And we see recently the European government very pragmatic and looking in the direction of technological neutrality. And technological neutrality is so critical here. There is an allowance now for biofuels, and they will vote for this to consider biofuels as a zero-emission vehicle. Same thing as an electric vehicle. And this is a completely game changer for our industry, because that makes sense. That's economic and that's clean. So we see a trend. We don't have much time here, but we see a trend moving from fossils through blends when we combine fossils and biofuels together. And then we're going to be moving to more biofuels as we have a higher production of biofuels, and that's economic. And in the end, we're talking about synthetic. But synthetic fuels, we also don't have a great belief now, because synthetic fuels depends on electricity, and we don't have clean electricity to synthesize these new fuels. But we are very focused in this biofuel sector. When we look into sustainable fuels, this is quite important. First generation biofuel that you take exactly from the oil you produce out of the crops. Ethanol from sugarcane, from cotton, from corn, or production from soybeans that you make biodiesel or HVO. They have a very similar costs to fossil fuels. But this will improve because the productivity of the land, as you improve seeds, as you change seeds, fertilizers, as you have more area to produce, this is likely to reduce the costs significantly in the coming years. Then you have second generation biofuels. Is when you take the residuals and you convert, but this is still expensive. But this is competitive to electrification today. And the synthetic fuels, which is still quite expensive because it's not a good use of electricity. It's better to use in the battery in this case, right? So this will be a very tough discussion. But if we don't reduce those costs, we don't see those solutions working fine in the coming years. We look in Brazil, just an idea of Brazil, of the waste we have from crop production. We could convert 70% of the diesel used in Brazil today. And this is happening. Brazil is the only country in the world where the increments of sustainable fuels is higher than the requirement now. So we are reducing the fossil fuels utilization in Brazil these days. Because we have, and when we look at globally, the global crop and protein residues, we have 171 billion tons a year of residuals from crop production. And this could be all converted into fuels, right? Into sustainable fuels. 44% of that are left out in the field, and they go through decomposition. But we need some technologies and need to focus on these technologies. A lot of companies are working on this, that we can do a fast and economical decarbonization after that. When we look in the areas, and there's a discussion about food or fuel, and this is quite important. When look, just talk about Brazil here, right? You see yellow and red in this chart. These are areas that were used or are still used for cattle raising. 23% of the country is used for cattle raising. And these areas, they are degrading because of that. Because as the animals eat the vegetation, you have rain, the minerals go deeper, so then you don't have vegetation comes back again. And then you have a process of desertification. These areas are good, and these areas can be very quickly converted for production, okay? Out of these 2.5 billion hectares globally, we believe 40% is economically viable. About 1 billion hectares of area that we can treat with fertilizers, and we could produce sustainable fuels. This is the area of great areas of opportunity to produce energies. Going back to Brazil, I mentioned these are the utilization of area in Brazil. 65% are native vegetation, 5% are cities, 7% is the agriculture. Brazil is the largest exporter of agricultural products in the world, and we use only 7% of our land for that. The 1% is the production of ethanol. We made a comparison, it's just an exercise. If we take 12% of the land, or half of this area that was used for cattle raising, that you don't need that to produce the cattle, if you confine the cattle, with 12% of the area producing ethanol of first and second generation, we could make up all the gasoline that's consumed around the world. This is amazing, and there's a lot of potential here to be explored. This is also another exercise. If we take 20% from total areas of restoration, we could produce 50% of the global diesel consumption. Or the gasoline. If we take care of 10% of the agricultural residues, we would produce 2.6 times more ethanol to replace the existing gasoline around the world. So the potential is here. There's a lot of research going in this direction. And the good news is that these are all liquid fuels that are gonna be processed inside the internal combustion engine. Tupy is working on this. I mentioned about solutions. These are a lot of solutions we have. This is a tractor, a John Deere tractor that will replace the engine with ethanol. That truck also we replace with the biomethane. And we are using this, but this will be a business for the big OEMs. Because as we see in the future, the world will be multi-fuel. We're going to have different fuels, different solutions in different parts of the world. Okay? It doesn't make any, we cannot have, and this is part of the discussions with the OEMs. The idea of electrification is good because you have just one problem, create electricity. You make one truck and you can make the same truck around the world. But yet what's happening, the market is reacting. The same reaction we saw on electric cars. The market is reacting. And like in Brazil, the producers of ethanol say, I want to run my machines on ethanol. I don't need to buy diesel to run my existing machines. I don't need to buy diesel if I can make HVO or if I can make biodiesel on my soybean plantation. So this is the ideas, and this is happening quite quick now. Moving on, as we see the opportunities for Tupy, just to finish. This is the market in Brazil. Tupy is a very important player locally. We see a market today is about 120, 140,000 trucks, but Brazil has the area of the United States, where they sell 500,000 trucks a year. Brazil will grow, no question about it. It has to grow, and will be an important player here. I showed in yellow, these are new business that we have that will help Tupy and also probably help SinterCast because they are likely related to CGI. And Brazil now is Euro 6, and we need the new technologies to support these emissions. When you look in North America, and now I have the share of engines, there are 5 engines running on Class 8 trucks in North America, okay? We supply components for 3 players. The other 2 players, they are our customers, but we do not supply them in this specific business. The areas in yellow are new business that Tupy is launching 2025 through 2028 that we are redesigning, our new products that also 70% of this will be also supportive for SinterCast business as we grow in these areas. Okay? We have announcements. You can look in our website. We have a recent announcement about the new products that we are doing, but we cannot announce everything that we have already signed in our contracts these days. So, as we look into the future, we have an entry of a new generation of engines, right? There will be a change in emissions in 2028, 2029 to Euro 7, and we are working on the design now of this new generation of engines, right? We are supporting blocks and heads to support that. What's important here? Pmax. The need, the pressure of combustion for these engines will be much higher than it is today. And to do that, you gotta have, to support these mechanical loads, you need a better material, then you're gonna need CGI for these applications. Also, I mentioned about going back to the business of pass cars. We realize there's a difference when you talk about aluminum. When the industry decides to go to aluminum, aluminum has a carbon footprint that's 10 times higher than steel. And the same thing applies here in comparison to cast iron. So when OEMs decide to make engines for aluminum, they increase the footprint of these vehicles. The problem is the regulation today does not cover from the cradle to the grave of these products. Good thing in Brazil, next year the regulation requires from the cradle to the grave. So you take all the carbon footprint of the construction of the vehicle, right? And you see lots of projects that we are discussing now. There's not decided if it's decided we will announce, but we have a lot of discussions to replace aluminum for cast iron for passenger cars. This makes sense. This is economic. This reduces the carbon footprint. This helps the environment, and this will help our business as well. So, just to finish, what we believe, demand for transportation, construction, and food production will increase, right? And we'll see growth because of income, because of population, because of life expectancy, right? Decarbonization will go through a combination of several technologies, and this will be applicable for each region of the world. Brazil will have a solution, Australia will have another solution, which is a country that's very rich in terms of their crops and their cattle production, so they have energy being wasted there. And look into Indonesia, the production of ethanol, or India or the United States. So you're going to see significant numbers of different sustainable fuels being produced in this region. And this sustainable fuel, they have to be consumed inside a reciprocal engine, inside internal combustion engine, right? So sustainable fuels are just starting. This is important to keep in mind. As we advance in batteries, we did a lot of things. Sustainable fuels is just the start. We have a lot to do in terms of technology to process this, to improve the seeds, to improve the productivity of the area. The expectation in Brazil, you can check this on the internet. There's an expectation that the production of sugar cane will double in 10 years per hectare. So why? Because they're changing the seeds, they're studying the DNA of the sugar cane, which is very complex, by the way. It's very much complex than what was made in soybeans, because now in Brazil, we produce soybeans in the tropical area of Brazil. Soybeans were only produced in the cold areas of Brazil or in other places of the world. And because of these advancements, we've been able to produce in these different regions. And this is likely to continue to grow in the coming years. So, no question, we truly believe internal combustion engines will continue to be the primary source of power for a variety of applications because we gotta do it economically. We are talking about essential needs of society. We're talking about sanitation, about transportation, production of food. This is not a luxury. This is fundamental needs of society. So that's it. So the sustainable future really depends on this world with zero emission, and we really believe ICE as part of our journey in life that we're gonna have to use this material, this waste, to produce liquid fuels and to make a true circular economy around here. Okay, thank you very much.